everyone. This is a project demonstration for our project predicting salary and identifying job security risk based on company location, size, and role. So we have created a data product for this project. Let me show you the data project. This is the GitHub repository uh, where we have put our code. We have deployed our project on Firebase. This is the front end of the project. And let's see the system design. So the architecture begins with raw data residing in AWS S3, serving as the source for the pipeline, Apache Airflow. And Apache Airflow orchestrates the entire workflow, ingesting data from S3 into Apache Kafka. Kafka acts as a streaming platform, enabling data to flow seamlessly into Apache Spark for large-scale processing and transformation. Once data is processed, it is stored in Snowflake, a cloud-based data warehouse where it can be queried and utilized. Predictions are then served via Flask API. Here we have created the backend in Flask, which interacts with the React which reacts with our frontend, which we have coded in React.js to provide users with the salary predictions. The entire system is containerized in Docker. We have used Docker Compose so that many of our servers can run simultaneously. We have deployed a backend on AWS EC2 instance to ensure automated error-free updates. And we have also integrated GitHub CI/CD. So as soon as we push our code to GitHub, the latest version of the code gets deployed. So let's see. Let's check the app. So here is the front end of our app where user can input values. Here you can select what is the experience type of the person and residence of employee residence and the remote ratio of the company and then the company location. So and company size as well. Now let's hit the predict button. So we get a salary prediction of $149,853. So this is how users can predict the data, predict a salary of a particular uh, field in a particular area, and you, students these days don't know which field to take. So this will help them that this is the salary expense. This is this even for people negotiating salaries with their employers. This is a nice uh, applications where they can find out that what is the current scenario and the pay structure of a particular company in a particular area in US. So this is the data product that we have created. Um, uh, let's see the system design again. So here is the Kafka Airflow. This is the complete flow that we have created. We start with the Kafka producer, consumer, then we do the get the data from the Postgres. Yeah, and one more thing. PostgreSQL here we have used. It acts as an intermediary database for us, and then we get the data process the data in Spark, and then we create the tables in Snowflake, upload the data in Snowflake, and then uh, validate the data. So this is our pipeline, flow pipeline, and we deployed the front end in Firebase, and we deployed the backend as well as other servers in EC2 instance. This is our running EC2 instance, that is DS server. This is the Snowflake. Whatever transformations we did are this is whatever transformations we did are you can see the transformations here. Here we have transform salary data, we have the salary table, then the prediction data. whatever we have predicted, it gets added into the table of prediction data. So uh, this is the Docker container. Uh, right now I'm running this in local as well. So 11 servers are running, excluding the front end, because front end I'm running at a different pace. But this version is deployed on Firebase for front end. So let's see the code as well. So this is the complete code structure for our app. Uh, Here we've got the backend where I've created the app.py, that is the Flask applications here we have. Then DAX. Then we have the full front end in React. Then we have Kafka producer and consumer architecture. Then in Docker Compose, we have starting with Spark master worker architecture. Then we have Spark history, it creates whatever logs we have done. Then we have PostgreSQL. Then we have Redis for that acts as a message broker for us, sending messages. This is initialization of Airflow. Then Airflow web server, Airflow scheduler and web server architecture. Then we have Airflow worker. Then Zookeeper that coordinates the task for Apache Kafka. Then we have Flask, Kafka producer and consumer architecture. So this is a complete data product where we have used linear regression as a machine learning algorithm for predicting the salaries. So thank you. Let's see the phase 3 code for PySpark processing, where we have imported the important libraries and we have created the Spark session. We have loaded our data, and this is the preview of our data, as you can see. Then we start accumulating the metadata of our project, that is printing the schema, number of rows, number of columns, and all the columns and the features of the data science salary data set. Then we moved on with data pre-processing, where we handled the missing values. We removed the duplicates using dot duplicates method. Then we used encode. Then we encoded the categorical variables using string indexer. Then we normalized using min-max scaler. First, we used vector assembler. Then we created derived columns as we had done in the phase 2 of the project as well. Uh, then we added a salary rank column to the data set and the salary range that is the same thing that we had done in the phase 2 using binning. And so this is how we did the pre-processing. Now let's move on with the predictive modeling. We had used 6 models, that is linear regression, random forest, GBT regressor, decision tree, generalized linear regression, isotonic regression, and FM regressor. So we moved on with the predictive modeling. We had identified the categorical and numerical columns, indexed and encoded the categorical values, and assembled features, standardized those features. Then we use the regression evaluator that is used for our RMSE. So then we use this function for all of our algorithms to find the RMSE and the R2 squares, R square scores for all of our uh, models. So here we got the RMSE and R score for all of our models. Then we saved this model so that we could use it for prediction, and we had used this for prediction. That is We provide the salary in USD, and the predicted value was see, you can see the difference between the actual value and the predictive value. So in all of these models, our linear regression model performed the best. So this is the code for phase three. We had done the comparison analysis with the phase two models and provided all the results in that table in the report. So that's it. Thank you. Now let's see the DAG visualization of our whole PySpark process. So as you can see, there is 925 completed jobs. And let's see the stages as well. There is 1039 stages. These are completed stages. You can see the DAG visualization of the last. As you can see the DAG visualization of all the stages in Spark in our whole process. So this is a complete project. Thank you so much.